Scientific articles describe experiments that have been conducted. An abstract is a brief summary of the entire article. It's incredibly important for readers so that they can quickly determine if this article will answer their question or if they need to keep looking. An abstract has 4 sections. The background or introduction describes background information on this topic. Methods describe the experimental design. Results describe the data that you actually collected during your experiment. And the conclusion or discussion answers the question, what does your data mean? We will discuss how to write each of these 4 sections and provide an example. The background should give the reader enough information so that they can understand the article. It should answer questions like, what's already known about this subject? What's not known about this subject? In other words, what question does your experiment try to answer? And why is your experiment significant? Why should people care about your findings? Let's do an example. This is completely made up, but let's say we want to study vitamin B and smoking. What's already known is that vitamin B is important for health and wellness, including mood. And smoking increases your risk of diseases like lung cancer and other respiratory diseases. What's not known is if vitamin B can decrease the cravings for cigarette smokers. So this study aims to find if vitamin B can decrease cravings for chronic cigarette smokers. Why should people care? Because vitamin B might be something we could add to the clinical care and treatment for people with addiction. Next is methods. This is where you describe the protocol or the experimental design that you followed. You should have enough information that the reader understands exactly what was done and how it was done. You should describe whatever subjects were involved in this experiment, whether those subjects were human, mice, bacteria, cells, plants, or something else. Next, describe your control variables. These are the things that you intentionally kept constant in your experiment. You may have conducted the experiment at a specific constant temperature or at a specific time of day. You may have controlled for features in your participants. Maybe you only used participants in a certain age bracket or a certain body weight or height or gender or something else. Next, describe the independent variable. This is the thing that you're changing to see if it has an effect. You should identify what the control group is and what the experimental group is. A control group is different from a control variable. The control variables are all the things that are being kept constant, whereas the control group includes subjects. We'll go over the difference in the example. Next, we describe the dependent variable. This is the thing that you anticipate might change in response to the independent variable. You should describe what was being measured and how it was measured. And lastly, how long did your experiment last? Using that same made-up example, let's say that we used 100 cigarette smokers as our subjects. We made sure that all of those smokers were male between the ages of 30 and 40. So we controlled for gender and for age. All participants smoke approximately 1 pack of cigarettes a day and have done so for at least 5 years. And all participants were provided an unlimited supply of cigarettes. They were able to smoke as frequently as much as they wanted. Now, if we hypothesize that vitamin B supplements might affect a smoker's cravings, then vitamin B supplementation is the independent variable. So one group of participants will get vitamin B and one group will not. You compare the group that did get vitamin B to the one that did not. The experimental group is the one that received vitamin B supplementation, the independent variable, and the control group did not receive it. Now, if we think vitamin B affects the amount a person will smoke, then our dependent variable is how much the person smoked. How can we measure that? By simply counting the number of cigarettes they smoked each day. Let's say this experiment lasted 6 months. So you collect data every day for 6 months. The results section should describe your data, and it needs to include some of the actual data you collected, some of the numbers. It might look something like this. Those who received vitamin B supplements decreased their cigarette usage by 8.8% over 6 months. Those in the control group did not see a significant change in cigarette usage. It's not enough to say those who received vitamin B smoked less cigarettes. You need to have some numbers in this section. It could look like this, where you use a percentage that you've calculated, or it could look like this, where you use the actual numbers. So the control group, on average, the participants smoked 20.1 cigarettes per day at the beginning of the experiment, and by the end it was 20.2, so not a big change. But in the experimental group, the one that got vitamin B, they averaged 20.4 at the beginning, and then it dropped down to 18.6 at the end. So you can use the raw data like this, or you can calculate a percentage like this. The conclusions, on the other hand, explains what this data actually means. Many people get confused on what the result is and what the conclusion is. So I'm going to show you some real data now, and we'll practice finding what the result is and what the conclusion is. Oftentimes, the word I'll use when I'm describing results is trend. So you're identifying the trend in your data. And when it comes to conclusions, I tend to use the word interpret. You're interpreting your data, interpreting what your data means. Here we have some real data. In red, it shows the total revenue generated by arcades, and the black line shows computer science doctorates awarded in the United States from the year 2000 to 2009. What trend can you see in this data? Think of it as if you're trying to describe this graph to someone who's blind. You can see that these two lines follow each other. So the trend might be, as computer science doctorates awarded in the United States go up, we also saw an increase in the total revenue generated by arcades. You don't really have to think about the trend. The trend is just the description of what you see. The interpretation, that's when you start to think about reasons and causes. Can you think of one interpretation of this data? One interpretation might be, the more computer science doctorates there are, the better arcade games are being developed, and therefore arcades will make more money from those superior games. Or another interpretation might be, computer science doctorates love to play arcade games. So the more doctorates there are, the more arcade games they'll play. But those are just guesses. This data doesn't prove for certain that more computer science doctorates causes there to be more money generated from arcades. This data doesn't show that arcades cause more people to pursue computer science doctorates. So your interpretation or your discussion, your conclusion, can't be, this data definitively shows that one thing causes the other, because this data doesn't definitively prove anything. All it's proving is that between the year of 2000 and 2009, there seems to be a correlation. If you want to prove that there's a cause and effect here, you have to do a little bit more. You have to generate an experiment that does actually establish cause and effect. Let's do another example. In red, we have the divorce rate in Maine, and in black, the per capita consumption of margarine. What's the trend? This data shows that the divorce rate and the per capita consumption of margarine decreased from the year 2000 to 2009. Or another way you could say it is that the divorce rate in Maine correlates to the per capita consumption of margarine. How might you interpret this data? One explanation might be that there's something in margarine that makes people unhappy. And so the more margarine you're consuming, the more likely it is that you will get divorced from your partner. This data does not prove that, so you can't say for sure that that's the cause, but you could suggest this as one possible explanation. Alternatively, you could suggest that divorced people use more margarine in their cooking. And so as more people get divorced, they start eating more margarine. From this graph, we don't know the truth. We don't know what caused what. We can only suggest possible explanations. What trend do we see here? We see that the letters in the winning word of the Scripps National Spelling Bee is correlated to the number of people killed by venomous spiders. What's the interpretation here? Well, unless the Scripps National Spelling Bee is conducted in the middle of a venomous spider habitat, there's no obvious connection here. And sometimes there is no connection. Here we see that the per capita cheese consumption is correlated to the number of people who died by becoming tangled in their bed sheets. This graph looks really convincing, but these two things have nothing to do with each other. So making a statement like, eating cheese causes people to get tangled in their bed sheets and die, is not a good interpretation of the data. You haven't proved a cause. So this is my reminder to you. If you didn't actually prove the cause, you shouldn't claim that you have proved a cause in your conclusions. Instead, you should use more specific terminology. Instead of saying that if you crown an older Miss America, more people will be murdered by steam, you should say, we found this correlation. These two things are probably correlated just by chance. We have no proof or reasonable explanation for why the age of Miss America might affect the rates of murder by steam. Let's apply this to our example. We saw that subjects that had vitamin B supplements decreased their cigarette usage by 8.8%. What conclusion can we draw from this? How can we interpret this data? Can we say definitively that vitamin B is the cause of this decrease in usage? We did control for a lot of things, but maybe the start of the experiment was around the holidays, which is very stressful for many people, and that's why they were smoking so much. Or maybe these people started to go to therapy and started making improvements on their addiction. There are so many things that could have been involved that we can't really say for sure what the cause was. So instead we say our findings suggest that vitamin B may be an effective way to help curb cigarette cravings in men. We don't say our findings show that vitamin B will curb cigarette cravings in men. This was a made-up example, but now let's look at a real example. In this article titled Sleep Quality in Cigarette Smokers, Associations with Smoking-Related Outcomes and Exercise, they introduce that cigarette smokers have poorer sleep quality, which is associated with greater nicotine dependence. They also explain that exercise improves sleep quality. So their goal is to explore the relationship between exercise, sleep, and smoking. They collected data on sleep quality. This is what they measured. And then they told you how they measured it by using this insomnia severity index. They measured smoking-related outcomes. And how they measured it was by counting the number of cigarettes they smoked per day. They measured exercise, and the way they measured it was by using a Fitbit activity tracker. They did this for 32 participants in a 12-week-long trial. They found that those who had poorer sleep quality experienced more withdrawal, craving, and smoking urges. In addition, increased exercise was associated with improved sleep quality. Notice this is just descriptions of the data. They're not saying one thing caused another. They're just describing the data. In conclusion, their data suggests that better sleep quality may be associated with lower levels of withdrawal, craving, and smoking urges. Again, nothing about one thing definitively causing another. They recognize that 32 participants is a rather small study, so they suggest that more research should be done to further explore their findings.